Hello friends, welcome to civil engineering exam. Today we are going to see the problem related with design of reinforced concrete elements. So in the topic of design of T-beams, okay. So the problem is a T-beam slab floor of an office comprised of a slab 150 mm thickness spanning between ribs spaced on 3 meter centers. So the effective span of the beam is 8 meter. Live load of an floor is 4 kN per meter square. Using M20 Fe415 HVAC bars, design a one of the intermediate T beam. Okay, so we have to design the T beam. So now the given values. So L equal to 8 meter. So then depth of flange is 150 mm. Then service load L or W equal to 4 kN per meter square. So then spacing between T beams is 3 meter. So then FCK is 20 Newton per mm square. So then Fy value is 415 Newton per mm square. Okay, so these are all the given values. So first solution step 1. So step 1, so we have to find out the cross sectional dimensions. Okay, so for cross sectional dimensions, so we have to take the first simply supported beam as simply supported beam. So span by depth ratio we can obtain from the IS 456, and we have to introduce the reduction factor because of T beams. Okay, so now the simply supported beam span by depth equal to 20. So now we can take width of we can assume width of rib. So width of rib is 300 mm. So then flange width. So flange width is 3 meter. Okay. So now the ratio between the flange and the rib. So now 300 divided by 3000. So we can take an as mm. So that is 0.1. Okay. So now we can take from 39. So we got the reduction factor. So reduction factor is 0.8. Okay, so now we got the basic span by depth ratio. So that the span by depth ratio is 20 into 0.8. Okay, so now we can take the span is length is 8 meter. So length is 8 meter. So now we can take 8000 divided by depth equal to 20 into 0.8. Okay, so now we can take D equal to 500 mm. So solving this we got the value of D. So D is 500 mm. Okay, so now assume capital D is 550 mm. So that is cover is 50 mm. Okay, so now the dimensions. So now the dimensions D equal to 500 mm. So then capital D equal to 550 mm. So then width of web is 300 mm. So depth of flange is 150 mm. Okay, so these are all the dimensions. So next thing we have to find out the loads. So determination of load. After that we can find out the moment and shear force. So now self weight. So self weight of slab equal to, so there is 0.15 into 25 unit weight of concrete into 3 meters. Okay, so now 11.25 kilonewton per meter. Okay, so next is floor finish. So floor finish is 0.6 into 3 meter. So now we got the value of 1.80 kilonewton per meter. Okay, so next thing is self weight of rib. Self weight of rib is 0.3 into 0.4 into 25. Okay, so now we got the value of 3 kilonewton per meter. So next thing is plaster finish. So slab is having the floor finish and rib having the plaster finish. So now we taken as 0.45 kilonewton per meter. Okay, so now we got the total load. So sum of all those things. So total load is 16.50 kilonewton per meter. Okay, so then live load. So this is total dead load, then live load. So live load is given, that is 4 kilonewton per meter. Okay, so then now the total load will be 20.50 kilonewton per meter. So now we got the ultimate load WU equal to 20.50 into 1.5. So now we got the value of 30.75 kilonewton per meter. Okay, so from that we can find out the ultimate moment and shear force. So step 3. So now step 3, ultimate moment and shear force. So now mu equal to W L square by 8. So now we can substitute 30.75 into 8 square divided by 8. Okay, so now we got the value of 246 kilonewton meter. Okay, so then shear force Vu equal to W L by 2. So now 30.75 into 8 divided by 2. So now we got the value of 123 kilonewton. Okay, so this is the shear force and this is the ultimate moment. Okay, so from that we can find out the width of the flange. So step 4. So width of flange. So now we can take formula BF equal to L0 by 6 plus BW plus 6 into DF. Okay, so now we can substitute 8 by 6 plus 0.3 plus 6 into DF is 0.15. Okay, so now we got the value of BF equal to 2530 mm. Okay, so the BF equal to 2530 mm. So next thing is we can take the center to center rib. So this is first condition. So second condition is center to center of ribs. So now we can take 3 minus 0.3, that is 2.7. So that is BF equal to 2700 mm. Okay, so from this least of 2 is BF. So BF equal to 2530 mm is the final answer. Okay, so next thing is moment capacity of flange. So now we can take step 5. So moment capacity of flange. So we can take MUF equal to 0.36 FCK B into BF into DF into D minus 0.42 into DF. Okay, so now we can take substitute all the values over here. 0.36 into 20 into the BF value is 2530 into, so DF is 150 into 500 minus 0.42 into DF is 1500. Okay, so from that we can get the value MUF equal to 1194 into 10 power 6 Newton mm. So we can convert into kilonewton meter. So that is 1194 kilonewton meter. Okay, so now we can take MU is less than MUF. So hence the width of, so XU is lies in between the flange. Okay, so now so XU, that is neutral axis, lies. So neutral axis lies within the flange. So hence the section is considered as the rectangular. So rectangle. So now B equal to BF. So step 5, next step is calculate the reinforcement. So now we can get the value. So ME equal to 0.87 Fy AST into D into 1 minus AST into Fy divided by FCK BD. Okay, so this is a formula. So we can substitute all the values over here. So MU is 246 into 10 power 6 equal to 0.87. Fy value is 415 into AST into 500, depth is 500 into 1 minus 415 AST divided by 2530 into 500 into 20. Okay, so solving this we got the value of AST. So AST is 1417 mm square. Okay, so this is the AST. So now we can assume 25 mm dia bars. So now we have to find out the spacing and number of bars. So now we can take number of bars equal to, so small AST by capital AST pi by 4 into d square, that is 25 square divided by capital AST is 1417. Okay, so now we got the value of 3. So now we can provide 3 numbers of bars. So then provide 2 numbers of 12 mm dia hanger bars in compression zone. Okay, so this bars is in tension zone. So this was so this 2 number bars in compression zone. Okay, so this is a compression reinforcement. So next thing is step 6, check for shear. Okay, so that is shear reinforcement. So now we can take shear force tau V equal to Vu by B into D. So now Vu is 123 into 10 power 3. So the shear force, so then V into D, that is 300 into 500. Okay, so now we got the value of 0.82 Newton per mm square. So now PT value, so PT is 100 AST divided by B into D. So now we got the value of 100 into 1473 divided by, that is AST value, so divided by 300 into 500. So now PT is 0.98. Okay, so now in IS 456 table 19, okay, so tau C value is 0.6 Newton per mm square. Okay, so now since tau C is greater than of tau V, so shear reinforcement to be provided. Okay, so now we can provide shear reinforcement. Okay, so now we have to provide the shear reinforcement. So now the shear reinforcement will be 8 mm stirrups. So 8 mm stirrups. So now SV spacing equal to 0.87 Fy AST divided by V into US. So now we can provide 0.87 into 415 into 2 into 50 into 500. Okay, so now divided by 33 into 10 power 3. Okay, so now we got the value of 547 mm. Okay, so now next thing is we can provide SV is not more than 0.75 into D, so that is or 300 mm. Okay, so here 0.75 into D is 375 mm. Okay, so now we can take least one, so least of 3, so that is 547, then 300, then 375. Okay, so now we provide 300 mm. Okay, so hence provide 8 mm dia bars at 300 mm spacing. So this is the final answer. So we can provide the tension reinforcement 3 numbers of 25 mm dia bars. Then compression zones, the hanger bars will be 2 numbers of 12 mm dia bars. So then we can provide the shear reinforcement 8 mm dia bars at 300 mm spacing center to center. Okay, so this is a method we can solve the problem. Again, we will see next video. Thank you.